Hello and welcome to another OXB Maths video on arithmetic progressions. Okay, today we're going to have a tricky one. Again, given it's an arithmetic progression, and given that the 1008th term is equal to 1, find the sum to 2017. Okay, that's it. And this is a pretty clever question, seeing that it's the year 2017. When you watch this, it might not be 2017, but it is right now. You're not given the common difference. You're not given the first term. So how do you find the sum to the 2017th term? Right. If you'd like to try this out, pause the video, and when you come back, we'll get you the answer. Alrighty, welcome back. So the question was, in an arithmetic progression, given that the 1008th term is 1, find the 2017th term. So there's a little trick involved here. As you know, arithmetic progressions are generally described as, first term being 1, second term being, first term being a, second term being a plus a common difference, third term being a plus twice the common difference, and so on and so on and so on. You can see that if you arbitrarily take, the second term, shouldn't write that. So if you take the second term to be some take the second term as your first term, right? And you'll see that T1 obviously is this minus the common difference. And T3 is obviously this plus the common difference. All right? And if you add these three terms together, right, sum of Tn from 1 to 3, you get 3 times of the middle term. Okay? And this holds true for any odd groupings of arithmetic terms. So for example, if you've got T1, T2, T3, T4, T5, okay, and that's equals to, as usual, okay, A plus D, A plus 2D, A plus 3D, and so on and so on and so on. Okay, you can arbitrarily rewrite the middle term, T3 here, okay, to be equal to some kind of term. And T2 is obviously that term less D, T1 is that term less 2D, T4 is that plus D, and T5 is that plus 2D. And conveniently, these common differences all cancel each other out, okay? And then you'll get the sum is equals to 5 times of A prime, right? Which is 5 times of T3, right? So you have the general identity that every time you have an odd number of arithmetic progression terms grouped together, the sum of all those terms is always the middle term times the number of terms. All right, the middle term, which in this case is T2, times the number of terms. Right? So conveniently for our problem here, you'll find that T1008 is equal to 1, okay, and you'll see that T1009 is equals to 1 plus some sort of common difference. T1007 is 1 minus that common difference, and if you extend all the way up to T1 and that to T2017, conveniently you'll find that this is 1 minus, okay, let me get my math right here, is minus 1008, this is plus 1007, no, 108, 105 I think, 107 D, and that's T minus 1007 of D. All right. So it just so happens that 1008 is actually the midpoint between 1 and 2017, right? which makes this problem have a little neat shortcut. All right, the sum of all these terms here, pardon that, is actually equals to all the common differences cancel each other out. Okay, and you get that equals to 2017 times 1, which is 2017. Let me just rewrite that more clearly. All right, so that's the answer. Kind of cool. Yeah, you're given very, very little information to start with, and you find that the sum to 2017 is actually 2017 itself. Okay, so I hope that was kind of a cool trick for arithmetic progression sums, right? Hope you enjoyed that. So till the next time, happy thinking out of the box. Bye.